Picking up at number 8, we got a probability problem. Since Carter has 153 songs on the playlist, he's categorized them in the following manner. We got 20 songs in country, 31 in blues, 8 in Latin American, 17 jazz, 26 rap, 14 folk, and 37 hip hop. If he begins listening to his playlist on shuffle, what is the probability that the first song played is a folk song? Okay, so on this one, if we look at it, it says there are 14 songs in the folk category. Okay, so there are 14 different songs that could start playing that would be a folk song. Out of, look, it says he's got 153 songs on the playlist. So out of 153, we have 14 out of 153. We can divide that, and you can leave it as a simplified fraction like this. That's okay. Or as we want to round it to the nearest millionth. Okay, so it's going to be really small. So let's just leave it as simplified fraction. Okay, it's about 9%. Change it to a percentage. Okay, so 14 folk songs out of 153 total possible songs. So 14 out of 153. Okay. Number 9 says we're rolling a standard die. That means it's a 6-sided die. Find the probability that the number rolled is greater than 2. Okay, so we think about a 6-sided die, the possible numbers we have, we could roll a 1, 2, 3, 4, 5, or a 6. Okay, so we want the outcomes that are greater than 2. So what would be greater than 2? Well, that would be 3, 4, 5, or 6. All right, so we got 4 of these out of how many total possibilities? 6. So we got 4 ways we could do that out of 6 total possibilities. If we simplify that, that is 2/3. 2 out of 3. Or you could write it as a decimal. Just do 2 divided by 3 and give the decimal version that way. Number 10, it's kind of deceptively short problem here. It says a mother duck lines up her 11 ducklings behind her, and how many ways can she line the ducklings up? Okay, so on this one, if we think about when she picks the first duckling, okay, and so we're picking the first baby duck who's going to be in front of the line, how many choices does she have? Well, she'll have 11 choices. Then if she goes to pick who's going to be in the number 2 spot, she doesn't have 11 choices anymore, right? Because she's already put one in the front of the line. So it's going to go down by 1, right? She's going to have 10 choices for the next spot. And 9 choices for the spot after that. And 8 for the spot after that. All the way down to when she runs out of ducklings. Okay? So we multiply all those together, 11 times 10 times 9, all the way down to 1. We can get the answer that way. Or another way we can write this, okay, this thing is the same thing as writing 11 factorial. So 11 with an exclamation point means this same thing. And it's going to be a surprisingly big number. Okay, so I'm going to do it the long way. I'm going to do 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2, and then times 1, even though the 1 doesn't change anything. And the number we get here, 3991680, so that is 39,916,800 possibilities, possible ways she could line up those 11 ducklings. So that's always mind-blowing to me that that number is so big. Okay. For 11. College's basketball team will play 31 games next winter. Each game can result in 1 of 2 outcomes, a win or a loss. Find the total possible number of outcomes for the season record. So if we start off thinking about this one kind of like the last one, if we just look at the first game, how many possibilities do we have there? Well, we only have 2, right? So for the first game that gets played, there are 2 possibilities. It's a win or a loss. What about the next game they play? How many possibilities there? But it's still going to be 2. Right? So there's going to be 2 possibilities for each game. And I'm going to be lazy and put some dots here. And how many of these 2s are we going to have? How many games are they playing? They're playing 31 games. So we got to do 2 times 2 times 2 times 2 times 2. 31 times. Or another way we can write that is 2 to the 31st power. Right, so we do 2 to the 31st power. Again, we get a huge number. 2, 1, 4, 7, 4, 8, 3, 6, 4, 8. So what is that? 2,147,483,648 total possibilities. Okay, number 12. We kind of got this idea already. It says evaluate the following expression. Gives us 9 factorial, or 9 with an exclamation point. So if you know where it's at on your calculator, you can do 9 and then the exclamation point. It will give you the answer. If not, it's okay to do 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. See what we get. This one we get 362,880. Big number there. Okay, 13. Got a vocabulary problem here. It says 4 scenarios of statistical studies are given. Determine which study uses a sample statistic. So we're looking to see if the number that is given in each one of these tells us about the whole population, or if it just tells us about some sample data. Okay, so A says a study prompted by the increase in the use of assisted reproductive technology looked at hospital records across the country. The report stated that an estimated 3.2% of births in the U.S. last year resulted in twins. Okay, that's telling us about all the births in the U.S. last year. It's not telling us that we took a sample in there anywhere, so it's not that one. B says the average finish time for the Ironman Kona was 11 hours and 32 minutes. For the 1,883 finishers with an average swim time of 1 hour and 14 minutes, an average bike time of 5 hours and 53 minutes, and an average run time of 4 hours and 14 minutes. Okay, so again, we're not taking a sample here because the 1,883 finishers, that's all of them. So those numbers are telling us about the whole population. So no sample statistic there. C says the National Institute of Pediatric Dentistry reports that 42% of children ages 2 to 11 have had at least one cavity. Again, that's telling us 42% of all children in that age range have had at least one cavity. We're not taking a sample, so it's not that one. Part D says of 351 dog owners who were surveyed, so there's where we're taking our sample, 70 reported owning 2 dogs. So since this is our sample, then that tells us this is our using a sample statistic. This 70 reported owning 2 dogs is our sample statistic here. And these other ones are population parameters. Okay, 14. Let's choose the term that best matches the given definition, a sample in which members of the population are divided into groups that are similar to the population. Data is collected from every member of the selected groups. Okay. So part A says a stratified sample. Okay, it's not A. And this is the one that's a little tricky. You can be confused here. A stratified sample, we take and we split our data into kind of different layers. Right, so these people in each one of these layers all have similar characteristics, and then we draw out some data from each one of the layers. Okay, so that would be a stratified sample. That's similar to what we're talking about, but that's not what we're asking for here. Okay. B is a random sample where you just randomly take your sample. That's not this one. C is a systematic sample where you have some rule, like every 10th person I see is going to be in my data. Okay, so the one we're looking for is D. I've got a cluster sample. So the idea with cluster sampling is, like it says here, we're going to take and split our population into little miniature groups, where every group is kind of like a miniature version of the whole population. And then what we do is we randomly select one of our smaller clusters to use as our sample data. And so the difference between cluster and stratified is that with cluster, we use the whole cluster that we choose. With stratified sampling, we collect some data from all the different strata. Okay. Number 15. The grades on the second statistics test for Mr. Brown's class are in the following list. Complete the frequency distribution table for the grades. So all we're doing here is we're counting. Okay, so let's see how many A's there are, and I like to mark them off a list. I can do that on the screen. You have to be careful if you're writing it down. Make sure you get everything included. But how many A's do we have here? Well, we just had one. What about B's? Well, we've got 1, 2, 3 B's. How many C's? We've got 1, 2, 3, 4, 5, 6 C's. Now, what about D's? We've got 1, 2 D's. And then 1, 2, 3, 4, 5, 6, 7, 8 F's. Must have been a pretty hard test. So we're just counting how many data values we have in each category to get our frequency distribution. Okay. Last one on this video, I'll post the rest tomorrow. Okay. So it says the following table represents a grouped frequency distribution of the number of hours spent on the computer per week for 57 students. What percentage of students use the computer between 4.5 and 8.9 hours per week? Round our answer to one decimal place if necessary. So the key thing here, we got two important things. It says we got a total of 57 students. Okay, we could get that by adding all these together. We would get 57, but it gave it to us, so that saves us a step. And then pay attention that it wants our answer to be a percentage. Okay? So if we look for this category between 4.5 and 8.9 hours, we had 18 students in there. Okay, so we had 18 students in this category. We got to change it to a percentage. So out of 57 total students, okay, so 18 out of 57, we divide that, we're going to get 0.315789, on and on and on. Change that to a percentage. We move our decimal place 2 places to the right or multiply by 100. So got 31 point, and it says round to one decimal place, so we'll round the 5 up to 6%. So 31.6% of people use the computer between 4.5 and 8.9 hours per week.